Okay guys, in this video what we're going to do is we're going to go ahead and we're going to code up the servo, make the servo move as the pot moves, as the potentiometer moves, and we're going to map the values from the potentiometer into the servo. Okay, so if you remember that the analog values of the potentiometer go from 0 to 1023, and the degrees of the servo go from 0 to 180. So the first thing we have to do is we have to map that from 0 to 1023. Like for example, if it's 0, this should be 0. If it's a 1023, this should be 180. You have to figure out a way to map that. So let's go ahead and go to our code. I don't like these blocks. I don't even know what they do. So we're not going to do that. Let's go ahead and go to code. Let's see if I remember how to do this. Text. Okay. So what we're going to do is first thing we have to do, let's get rid of all this junk. We have to put hashtag include servo.h. And what this does is there's a library built in the Arduino called the servo library, and this will allow you to access the servo functions, little methods that are built in. Okay. And we're just creating an object called myServo, which we're going to use. And now we're going to create some constants. The pot pin is A0. So if we look, is it? Let's see. Yep, it's A0. If it was, if we moved it to A1, it would be A1. Let's go ahead and do our pot val. We're going to get this later. Angle, we'll calculate that later. Okay. So in the setup function here, what we need to do, is we need to go ahead and we need to attach the servo to the port. So this servo, if we look here, it's port 9. So we're going to say servo, myServo dot attach 9. So now it's attached, and we're going to say serial.begin 9600, just so we could see the output. Okay, now we're going to do our loop. Okay, so the first thing we have to do in our loop, we have to say pot val. Remember, this is going to be executing every time, equals. Remember the two reads? We have analog read and digital read. So we're going to go ahead and read the pot pin. So why are we analog reading the pot pin? Well, if we look, it's an A0. And remember, this returns a value between 0 and 1023. Okay? Let's see here. Serial dot print. This is debugging stuff. You don't really need this, but we'll put it in anyway. Oops. Now, I don't know if you guys remember this, but you notice one has quotes and one doesn't. So this will be a string. It'll treat it like a word, and this will actually retrieve whatever the pot val is. So and it'll replace it. So it'll read what's in the pin, and it'll replace it with the pot val. Okay. Angle. This is a little tricky. I'll explain what this does. Pot val. The pot val goes from 0 to 10 to 1023, right? And we want to map it into 0 to 179. This means I misspelled angle. Excuse me. This means that we're going to read the pot val, and we're going to take between these values, and we're going to map it into this. So if you were to use your calculator and you were to get like 800, so you'd take 800 and divide it by 1023. So we could do that right now. You could take 800 and divide it by 1023, and we get 0.78. Now, if we look here, well, how would that map into 170? We're going to multiply it by 170, and it's going to equal 132. Okay, so that will be 132. Let's try another one. Let's say we read in 406. So we divide that by 1023, and we're going to get 0.39. We're going to multiply that by 1023, by 179, because that's the servo angle, and we're going to get 71. So that means that if we have that angle, the angle will get mapped into 71 degrees from the pot. Okay, so hopefully that makes sense. That's what that's doing. Let's go ahead and, I'm lazy, so I'm just going to do this. Okay, so again, this is debugging. All right. And let's go ahead. This is important. I bet you guys guess what, you know what this does. What this does is this gets the angle and it'll write into the servo. So it'll actually move the servo. And we're going to throw a little delay in here. I guess 15 will be enough. I don't really know. You guys might have to play with that. I'm on, we're going to be on the simulator, so this is a little different than real life. We already know that. All right, well, moment of truth. Let's go ahead and test this thing. Okay, I have a problem here. I forgot my semicolon there. All right. So I think I flipped these. Okay. So I think we have to take this. Let's try putting 12. Let's see if we're still blowing them up. Nope. That's good. Okay, now this isn't doing a whole heck of a lot. Let's see if we have it hooked up right. Power. Okay, see this one to power? And this is the ground. I mixed them up. So if I did that, you see how I did this? This one is ground. So I have to do this. I messed it up. And this one is power. Again, this is part of the process. We might have to go and, figure out what you did wrong. It happens. Okay. This one blew up. Okay. This one did because this is negative and this is positive. So this is the wrong way. This is bad. If you actually did this on your Arduino, you'd blow it up. This thing would actually explode. That would be bad. Right? We don't want things to explode. Let's do this. Okay, now let's play it. All right. So check this out. And let's look at our you could actually watch your serial port. Let's check it out. See, it's giving you the angles here. Let's do one thing. Let's just stop our simulation and do a print ln. And let's do a print ln, just so we could see some. Okay. So 532 is mapping to 88. Let's see what 0 maps to. 0 maps to 0. Let's see what 900 maps to. 900 maps to 149. Let's just test it. Let's make sure our math is right. So we see that 900 maps to 149. Let's see. 900 divided by 1023 equals, okay, times 179. Whoops. So 0.879. 0.879 times 179. 157. What do they get? Yeah, close enough. Close enough. See? And it's moving. It's controlling our servo. This would actually move a lot faster if you take the delay off. Watch. This is kind of neat. Go ahead and take that off. Watch this. It's pretty cool. So what we've done here, let's just analyze the code real quick, is we've created this simple program that attaches a servo and moves the servo around. Not a whole lot of if statements, Not much at all. So what I'm going to do is I'm going to write an assignment for you, and I'm going to ask you to write 3 programs. Okay, each program is going to ask you to add some stuff in, like LED, another servo, things of that nature. You actually could run this program, just so you know, you could use servos without capacitors. Watch. Oops, don't want to do that. Let's undo this. Okay. So let's go ahead and do this. Get rid of that. Get rid of that. So the program will still work. You know, the code, everything still works without a capacitor. The capacitor is technically more correct, but for the sake of our experiment, you could actually do without the capacitors. When I'm giving you your extra work, you don't need the capacitors. You can put them in if you want, but you don't really need them. It'll still work okay. All right, so hopefully you understand what's going on here with the servo business. I'm going to give you some example code in case you guys forgot how to work with an if statement for your assignments. And I'll write up 3 pretty basic assignments, not too bad. And you'll have to develop some circuits in here. I'll explain to you how you grade it, so I'll do it in the video. What you're going to do is you're going to take a picture of this. You're going to put it on a Google Doc, and then you're going to take a picture of the code. You're going to put that in a Google Doc, and that'll be how you're going to turn it in. Okay, so I'll go ahead and write these assignments up. This is how it'll work. And just to end the lecture, I hope everyone in your family is healthy. I hope you guys are healthy, and I hope to see you guys soon. Thank you for watching.